far beyond the measured stillness of our solar system, past the orderly paths of planets tracing perfect ellipses and comets unraveling their icy trails like breadcrumbs in space. Something unusual is stirring. It is not shining, not spinning, not flickering. It is pulsing, like a heartbeat echoing through the darkness. Every 16 hours, without deviation, the brightness of the interstellar object known as Threeey Atlas rises and falls, as though an unseen mechanism were breathing in and out, expanding and contracting, imprinting a steady rhythm onto the void. Scientists expected dust clouds, volatile gases, sublimation, even chaotic bursts, because comets are inherently unruly. What they did not expect was precision. They did not anticipate a cosmic metronome. And they certainly did not expect an anomaly so unsettling that some researchers are now quietly questioning whether they are observing a natural phenomenon at all. Tonight, we step into the mystery no one saw coming, the heartbeat of Threeey Atlas and the 14 anomalies that led us here. NASA's latest briefing has attempted to frame Threeey Atlas as a familiar visitor, a natural interstellar traveler with an icy nucleus containing carbon dioxide, water, carbon monoxide, cyanide, and traces of nickel, a body wrapped in a predictable coma, following a harmless trajectory that keeps Earth safely out of reach. From this official standpoint, the behavior appears routine, a comet releasing gases, glowing gently as it moves toward the inner solar system, and passing Earth at a comfortable distance of 270 million kilometers on December 19th. This is the version of the story meant to reassure, the one designed to let the world rest easy without imagining alien relics humming silently through space. The emphasis stays on what is normal, what is expected, what fits neatly within decades of prior observations. Yet beneath this carefully polished explanation lies a growing problem. Threeey Atlas has been anything but predictable, and the heartbeat anomaly is only the latest fracture in the narrative. While NASA continues to describe the object as a natural comet, researchers such as Avi Loeb, along with others who prefer to remain less visible, argue that humanity may be overlooking subtle technological signatures simply because science tends to discard what feels too unfamiliar. They are not claiming outright that the object is artificial. Instead, they point to inconsistencies, a growing list of anomalies, each one individually explainable, yet collectively difficult to dismiss. In their view, rejecting possibilities because they feel uncomfortable is not scientific caution. It is avoidance. The heartbeat phenomenon only intensifies this concern, because periodic behavior in the coma rather than the nucleus challenges long-standing assumptions about how comets function. Despite public assurances that Threeey Atlas poses no danger, NASA has selected it as the focal point of a large-scale planetary defense exercise, coordinated with the United Nations and space agencies worldwide from November 2025 through January 2026. This is not a casual choice. The object is being used to test observation methods, refine orbital calculations, and rehearse emergency communication protocols. In effect, humanity is practicing for the day a real threat appears. The decision raises obvious questions. If the object is truly harmless and entirely typical, why anchor a global defense simulation to it? Viewed through this lens, the heartbeat anomaly becomes even more provocative. Threeey Atlas is being studied as if it were a lesson, whether deliberately sent or not. Loeb also highlights a remarkable coincidence. Threeey Atlas aligned with multiple planets and adjusted its trajectory just enough to pass extremely close to Jupiter's Hill sphere, almost as though it were intentionally targeting that gravitational boundary. The odds of such an alignment occurring naturally are estimated at roughly 0.00004%, lower than the chances of winning a major lottery. More unsettling still, the acceleration required for this adjustment occurred while the object was hidden behind the Sun, beyond the reach of direct observation. NASA later revised its calculations and classified the maneuver as a natural effect. But if the change was caused by jets, sublimation, or something else entirely, it draws a direct parallel to the heartbeat anomaly, as both imply unseen forces operating with precise timing. While Threeey Atlas was obscured by the Sun, any alteration in its path went unnoticed by telescopes. When it re-emerged, NASA updated the trajectory to match the new data, attributing the discrepancy to standard non-gravitational effects. Loeb argues that if the object were technological in nature, this hidden interval would be the ideal moment for a propulsion-based correction, whether natural or artificial. The timing aligns uncomfortably well with the rhythmic brightness variations observed later, changes in motion and luminosity occurring just out of sight, yet leaving measurable traces behind. One might expect an object this unusual, this controversial, to be under intense scrutiny by the world's most powerful observatories. Instead, there are no new high-resolution images from major telescopes we typically rely on for definitive answers. The absence is striking. Much of what we see comes instead from amateur astronomers using equipment costing less than $3,000. Despite their limited resources, they have captured remarkably detailed images showing strange structures, multiple tails, anti-tails, and jets that should already have prompted deeper professional investigation. The lack of major telescope imagery almost feels like a tease, as if only fragments and shadows are being revealed before the heartbeat itself came into focus. Amateur observers across the globe have photographed Threeey Atlas displaying both a narrow tail and a distinct anti-tail, a configuration that already strains conventional models. Images from Utah show the anti-tail pointing toward the sun as expected, while the main tail diverges in a different direction altogether, forming an inverted V-shape. Comets do not typically violate solar-driven physics in this way unless internal forces are pushing material in multiple directions. And those internal forces may be closely related to the same mechanisms capable of producing rhythmic jets and pulsing behavior. Photographs from Tarasak Talong in Thailand reveal two prominent jets extending from the object, including another anti-tail directed sunward. These jets are structured and well-defined, and in some frames they appear to shift orientation in ways that defy simple explanations based on sunlight alone. This kind of variability is precisely what one would expect from periodic outflows of material, shaped by an unseen rhythm repeating every 16 hours. Other observers, including Sater Marata and Julian Winter, captured elongated debris streaks trailing behind Threeey Atlas, forming what looks like an atmospheric wake stretching across space. The repeating patterns, consistent spacing, and changing angles from night to night suggest processes that are cyclic rather than random. These recurring structures seem to foreshadow the heartbeat discovery, hinting early on that the object operates with an internal order instead of chaotic, one-off eruptions. Loeb's most recent analysis confirms that Threeey Atlas exhibits brightness variations with a precise period of 16.16 hours. Initially, researchers assumed this was simply due to the rotation of the nucleus. That explanation collapsed when Hubble observations demonstrated that more than 99% of the observed light comes from the coma, not the nucleus itself. The nucleus is too small and too faint to account for the fluctuations. Something within the coma is pulsing, expanding and contracting like a heartbeat hidden inside a cloud of gas and dust. And that is where the mystery shifts from unusual to unprecedented, with the nucleus contributing almost no visible light. The rhythmic signal cannot be explained by rotation alone. Something else is driving the pulse. Instead, Loeb proposes that only specific regions of the nucleus, rich in volatile ices, are exposed to sunlight as the object rotates. When these areas heat up, they release periodic jets of gas that cause the coma itself to swell and recede. It resembles a geyser erupting on a strict schedule, exhaling outward every 16 hours. The intensity of a coma's response suggests that enormous amounts of material are being expelled during each pulse. Data from the James Webb Space Telescope indicates that material released in a single cycle can travel as far as 25,000 kilometers. More than enough to visibly reshape the coma. Is like watching a balloon repeatedly inflate and deflate. Except this balloon spans tens of thousands of kilometers and keeps perfect time. This rhythmic breathing is exactly what one might expect from a system whose output is being regulated, much like a repeating exhaust cycle. Even though natural explanations are still possible, if the heartbeat were driven by a technological mechanism, the jets would not be required to align with the sun at all. They could be oriented in any direction. Interestingly, some images do show jets emerging along multiple axes, not all of them pointing sunward. Still, because complex natural explanations remain viable, the scientific community defaults to them. Artificial origins are always considered last. Yet when the trajectory adjustment, the anti-tail irregularities, the unusual dust formations, and now the heartbeat are considered together, the natural explanation begins to feel increasingly stretched. Loeb emphasizes that the brightness variations do not originate from a nucleus itself, but from the jets. Each outburst subtly alters the object's rotation and reshapes the geometry of the coma. In effect, the same forces responsible for the heartbeat are also influencing its motion. This creates a striking parallel. Even if the object is entirely natural, it behaves in ways eerily similar to a probe that adjusts its orientation using short bursts of propulsion. At that point, the boundary between natural behavior and deliberate design becomes difficult to define, because the underlying physics would be identical, even if Threeey Atlas were technological in origin. Loeb argues it is far more likely to be a relic, an ancient artifact no longer under active control, drifting through interstellar space, much like Voyager will one day do. A civilization encountering Voyager billions of years from now might misinterpret its strange emissions as signs of life. Even though the spacecraft itself would be long inert, Threeey Atlas could be similar, a remnant of engineering whose creators disappeared eons ago. The heartbeat might be an automated process, a residual mechanism, or simply a natural sublimation cycle that happens to resemble purposeful behavior. The next critical moments, including December 19th, 2025, when the object makes its closest approach to Earth. The wave of data expected from Mars and major telescopes in late 2025 and early 2026, and the close pass near Jupiter on March 16th, 2026, may finally reveal whether the heartbeat is merely an oddity of nature or evidence of something far more consequential. Loeb cautions that the real test will lie in how the object behaves during these encounters. If the 16-hour pulse continues unchanged, grows stronger, or shifts in unexpected ways, the debate will intensify like never before. Until then, all humanity can do is observe the quiet rhythm of this interstellar traveler as it moves through our cosmic neighborhood. As researchers continue to examine the growing list of strange behaviors associated with Threeey Atlas, a subtle paradox begins to emerge, one that becomes harder to ignore with each new data point. Individually, every anomaly can be explained by some natural mechanism: a misaligned tail, an unusually dense anti-tail, an unexpected loss of mass, a trajectory correction that conveniently occurred while the object was hidden behind a sun, a steady pulse of brightness repeating every 16 hours. The issue is not any single anomaly on its own, but the fact that all 14 are present at the same time. Science often treats each strange behavior in isolation, supplying a tidy natural explanation for every individual detail. But this piece-by-piece method sidesteps a far more unsettling question. Why is a single interstellar object displaying so many unlikely behaviors all at once? Is like walking along a shoreline, noticing one odd footprint and dismissing it as erosion, then spotting 20 more arranged in a deliberate pattern and still insisting it is random. Eventually, coincidence stops feeling accidental. Threeey Atlas crossed that threshold long ago, and the newly discovered heartbeat only deepens the mystery by adding precise rhythm to an already baffling collection of events. We are moving quickly toward a point where incoming data will collide with the comfortable interpretations institutions have leaned on until now. While NASA continues to assert that everything about 3I/2I Atlas can be explained through natural processes, it also acknowledges that definitive answers will not arrive until fresh observations from missions such as Juno, JUICE, and Psyche become available in early 2026. Those missions, along with close observations near Jupiter in March 2026, will test whether the heartbeat persists, changes, or vanishes entirely. If the 16-hour cycle remains steady as the object experiences shifting solar exposure, gravitational influences, and thermal stress, the strain on purely natural explanations will only increase. This looming confrontation matters because it exposes a core tension within science itself, the urge to classify the unknown as quickly as possible versus the responsibility to remain open to interpretations that feel uncomfortable or improbable. Threeey Atlas is pushing science into a corner, demanding clarity at a pace nature rarely allows. And each passing pulse feels like a countdown toward that reckoning. If we step back and view the heartbeat not as a metaphor, but as a physical process driven by periodic jets, it becomes clear that the interior of Threeey Atlas must contain structural or compositional zones capable of producing extremely regular outbursts. Loeb suggests that regions rich in volatile material are exposed to sunlight at precise intervals as the nucleus rotates, releasing gas in bursts that push the coma outward every 16 hours. Yet this explanation carries deeper implications. The nucleus would need to rotate with extraordinary consistency, and the volatile pockets would have to be arranged in a pattern that repeats with near-mechanical accuracy. Natural objects rarely sustain such stable periodicity over long periods without disruptions. The fact that the coma, rather than the nucleus, produces most of the visible variation adds another layer of complexity, because it means the object's breathing involves tens of thousands of kilometers of material expanding and contracting in unison, like a cosmic lung, whether the cause is natural or not. This rhythm suggests a level of internal organization unlike anything previously observed in an interstellar visitor. What makes the heartbeat anomaly so compelling is not just the pulse itself, but the growing sense that Threeey Atlas is approaching a stage where ambiguity will no longer be possible. The close approach to Earth on December 19th, 2025, the extended observation campaigns into early 2026, and the high-stakes encounter near Jupiter's Hill sphere in March 2026 form a timeline that feels almost like a scheduled revelation. If the object behaves consistently through all these transitions, continuing to pulse while its coma structures evolve in ways that either align with or defy solar-driven models, we may finally reach a moment where the natural explanation either stands firm or collapses. This tension is heightened by the fact that, despite repeated official reassurances of normalcy, the object remains profoundly strange, surrounded by coincidences, irregularities, and now a rhythmic signal that feels almost deliberate. Scientists like Loeb argue that maintaining an open mind is essential, not because an artificial explanation is preferred, but because refusing to consider it limits discovery itself. In that sense, Threeey Atlas is more than an interstellar visitor. It is a philosophical test of humanity's willingness to face the unknown without dismissing it too quickly. And so we find ourselves standing at the edge of an unfolding mystery that refuses to fit into any category we have built, watching an interstellar object breathe in the darkness like something alive, releasing pulses of light every 16 hours as if keeping time in a language we do not yet understand. For months, scientists have worked to reassure the world that everything about Threeey Atlas is natural, that each anomaly, no matter how unsettling, has a foundation in physics and chemistry, that the jets, the anti-tails, the improbable trajectory correction, and the rhythmic heartbeat all fall within the realm of cosmic coincidence. Perhaps they are right. Perhaps this is simply a profoundly unusual comet putting on a once-in-a-lifetime display as it passes through our solar system. But the universe does not owe us ordinary, and some of the most transformative discoveries begin with the courage to admit we do not yet understand what we are seeing. Researchers like Avi Loeb argue that closing our minds too quickly does not protect science. It constrains it. If we never look beyond the familiar, we may fail to recognize the extraordinary even when it is pulsing directly before us. Whether Threeey Atlas is natural or artificial, whether it is a drifting relic of a long-vanished civilization or simply one of the strangest pieces of frozen matter ever observed, is already teaching us something essential. Discovery demands curiosity, humility, and the willingness to confront the unknown without fear. The months ahead, December's close approach, new data from Mars, and an encounter with Jupiter's gravitational boundary will bring clarity one way or another. Until then, we are left with a heartbeat echoing across millions of kilometers, a reminder that the universe is far more mysterious than we often allow ourselves to believe. And if this object truly carries answers about what lies beyond our small corner of the cosmos, We will be here when those answers emerge, ready to see the universe not as we expect it to be, but as it truly is.